Hello, hello. Good morning, all. All of the students, please be fast and join it very urgently. Students, please tell to your friends to join the session very urgently. Yeah. Now, we will be let's start. For the yesterday's lecture, we have just gone about some kind of characteristics about the op-amp. Op-amp, it is nothing but an operational amplifiers. So for that, we are going to be considered some of the AC characteristics and the DC characteristics. Um, uh, we are just going through these parameters again in deeply for the next lecture. But for the yesterday lecture, we have just gone about what do you mean by the AC analysis, DC analysis, differential input resistance, how it is going to be calculated. So for the differential input resistance, as its name suggests, it is measured on the input side, and it is a differential because we are going to be considered the difference which is available between the two transistors, and hence it is nothing but called as an input differential resistance. So it is an equivalent resistance that would be measured at either of the input terminal, that is at the base of the transistor 1 or the base of the transistor 2, keeping the other the either of grounded. So keeping the other terminal as an grounded, that we have already seen, that is either you can be measured with an Ri1, Ri2 in the form of the base with the help of an base itself. Similarly, we can be just measure the output resistance. The output resistance we are obviously measured at an output side by keeping the another terminal towards the zero. Now, please be remember, for any of our building the circuit, we will be required to measure the resistance. So ideally, we should have to be keep the input resistance to be infinity, so that any of the external unwanted source cannot be entered into the your device. And at the same time, you should have to keep the output resistance to be as minimum as possible. Ideal value of the output resistance should be equal to 0, so that whatever the output we have get, that will be available as it is towards the user, so no any opposition. So this one is a common logic that we have to measure, that input resistance should be infinity and output resistance should be of an 0. So we can be measure the output at the obviously output resistance, this one is available at the collector side, and that's why it may be equal to R01 and R02 is equal to RC. So for the output, 1 for the transistor 1 and 2 for the transistor 2, and so on. Now for the today's session, we are going to see one another important concept. That one is called as a level translator. Now, as in the introductory session, we have already known that the IC is nothing but an integrated circuit, which will be consist of n numbers of n circuits. That one is called as an IC. That kind of the amplifiers may be in IC format. The different kinds of n circuits are available. That is, in some ICs, the cascading of the differential amplifier may also be available. Cascading means chain of the amplifiers. The output of one amplifier is given as an input to the next amplifier, then its output is given to the another one, and so on. So making the chain is nothing but called as a cascading. So if this one is an if this kind of the situation will be arises while we are building out any kind of a circuit, then in that case a special kind of a circuitry will be required, and that is nothing but called as a level translators. So what happens in the level translator is that when we are cascading the differential amplifiers, we can say that because of the direct coupling, the DC level at the emitter rises from stage to stage. I again explain this. What is this direct coupling of the DC? The thing is that whenever we are moving from one stages to the another one, the DC value is going to be increases. Now listen, what I want to say is that DC means how transfers, it is going to be transfers the uh, just a minute. This one is the transfer of the DC level to the to zero level. So whenever we are representing any of the term in a form of the AC characteristics, this one is nothing but an ideal situation. That is, this 0 volt is representing the DC as an 0 volt, and with respect to this 0 volt, I am going to be representing these changing parameters. So here it is going to be considered that this one is positive maximum magnitude is plus 1 volt and negative maximum value is minus 1 volt. So we can consider this one is one example I'm just putting in front of you. So this one is an ideal condition, that is this much of the amplitude is 1 volt. I'm going to be measure it with respect to 0 volt. That means here the DC component will be provided at the 0 voltage, and then based on that I'm going to be measured or draw this AC waveform having its amplitude as 1 volt and minus 1 volt. Now, if this DC level is not, transfer the DC level to 0 only. If this one is not the condition, that is ideally the DC component should be resting on the 0 volt. But instead of that 0 volt, if the DC component is going to increase and it is resting at a 2 volt, then and keeping the AC parameters as the same one, that is plus 1 volt and minus 1 volt. That is 2 volt plus 1 volt. Now the amplitude will be comes towards the 3 volt, and 2 volt minus of 1 volt, it will be comes towards as a minus 1 volt. So in this way, we can say that your amplitude is going to be what is required. This is required plus 1 and minus volt. But due to the shifting of the DC voltage level, now it will be given you the output as 3 volt and minus 1 volt. Which one is on a wrong one? So to keep our output to be a ideal one or the to be correct one, we should have to be measure this AC component with respect to the DC towards the 0 level. Transfer DC level to 0 level only. The AC component will be remains as the same it is. Here, what happens in this situation is that your DC components are going to be shifted, and all the remaining components will be remains as it is same one. Now with this, that is with the help of this level shifting, the DC signal, whatever this improved DC level, that we have to remove when it appears with the AC. So this one is on the main purpose why we will be required the level shifting. Or if you get it. So this one is an ideal condition. If any of the due to any situation, due to any circumstances, this DC level is shifted, then we will be get some kind of a different output with when it will be appear with an AC. So in that situation, to avoid this much of the difference, we will be required the level shifting circuits. Nextly, another one thing that we have to be considered over here is nothing but another one use that why the level shifting circuit is met. For example, I have already told you that the integrated circuit, which is consist of an n numbers of n circuits. So let's consider this one is an one circuit required for the required over here. This one is on a one circuit which will be required as an input volt as an 1 volt. This one is on a one another circuitry, which this one is one IC which will be built up of an 3 different circuits. So this is one circuit which will be required input voltage as 1 volt. This is an one another circuit which having the specification that it will be required an input as an 2 volt, and this one is an another a 5 volt. The thing is that there are the 3 different circuits which are demanding the 3 different kinds of inputs. But it is not possible that when we are constructing this on some kind of the common platform to provide the different power supplies to each and every circuit, it is not quite good practice and not possible to give it easily. So what we are doing that we are giving some kind of a fixed input voltage as far as if we are considering this one is an IC. So we are giving one fixed input voltage as a 5 volt. Now just this 5 volt to apply or to work out these different kinds of a circuit, it is necessary that this 5 volt should be converted into this 1 volt for this particular circuit. This same 5 volt should be converted into 2 volt and 5 volt for this circuit, and so on. So for this conversion also we will be required the level shifting circuit. So for mainly for the interfacing purpose also this kind of level shifting circuits are required. So in many of the situations we will be required many external DC supplies, so we can interface many of the circuits with the help of level shifting circuits. Okay, now we will be just see again there is one another reason why the level shifting circuit is required, that is it is reduces the propagation delay. Propagation delay, that means delay in some kind of a calculation. So if the propagation delay is going to be decreased, that means your circuit is responding fastly, so activity is going to be fast. You can say that the circuit is giving you the output as a faster one. So that is a very important parameter, that if the propagation delay is going to be reduces, you get the faster output. It also reduces the voltage swing. I'm going to explain this one in detail, that is what is the meaning or what is the purpose for this one. Reducing the voltage swing means what? Now let's consider, we have already seen the basic block diagram of the op-amp. So within that there is a first stage. Here is I'm just going to be try to make some kind of a miniature type of a circuit, which will be again explains this how the or in which situation these level translators are required. So this one is in a block diagram. In the block diagram of the operational or the differential amplifier, we have already seen that there is a first stage, there is an intermediate or the second stage. The first stage is nothing but an dual input balanced output. Then that output is given to the second or the intermediate stage, that is nothing but called as the dual input unbalanced output. And now it's dual input unbalanced. Unbalanced means we are measuring the one of the output with respect to ground. So in this situation there may be some kind of the AC as well as an DC components are available at the output of an second stage. Now this one is an actual circuitry of the level translator. Okay, that means this AC plus DC output is given to this kind of a circuitry or level shifter. In this level shifter we are keeping this one. This one is nothing but an collector, this one is an base terminal, and this one is nothing but an emitter terminal of the transistor. This one is a transistorized circuit. Basically it is given with some kind of an emitter follower kind of a circuit, and this one is the branch which is representing as the voltage divider network. I explain one by one. Now the thing over here is that whenever, that means with the help of a dual input unbalanced output, that one is on the second stage of the op-amp, that output is now available at the base of the transistor. Okay, now that base of the transistor, that whatever the input is given, that may be available same as it is in the emitter, in if this circuit is working as an emitter follower circuit. Whenever this kind of a facility is available, that is the input, whatever the input is given, the same is available at the emitter side, then it is called as an emitter follower circuit. That is, emitter is going to be follow with an input circuit. So that is nothing but called as an emitter follower circuit. So that is given over here. Now listen, when in some situation in the dual input, that is on a second stage, dual input unbalanced output, some of the DC components are present. That means instead of a 0 volt, your reference level is going to be shifted out. That is the maybe the same available at the base of the transistor, and now due to the emitter follower circuit, that is on the same available at the emitter. Okay, so that is on the same emitter voltage will be available. That means in emitter voltage in this situation is greater than that of an ideal situation. Now what happens due to this one? We know that we are measuring the, in the DC analysis we will be required the Q point, and in the Q point we are calculating the collector to emitter voltage. We are calculating the collector to emitter voltage, that is nothing but an VCEQ. How we are calculating collector to emitter? That is VCQ is equal to VC minus of V. Okay, that is nothing but a voltage drop will be taken from the collector to emitter. Now, due to presence of some DC values, the emitter current, emitter voltage is also going to be increased. That means this quantity is going to be increased. As this emitter value is going to increase, this collector to emitter, that is in a VCE value, is going to decrease because this VC is increases. Yes, and as the VCE value is going to be decreases with the help of the Q point characteristics, the Q point is going to move in the upward direction. As the Q point is going to move in the upward direction, that means it is going to be shifted from active region towards the saturation region. In the saturation region, as its name suggests, saturation means there is no any, if though you are giving the input, the output is not going to be changed. We are using this transistor as an amplifier. That means we are expecting that though I am giving the less input, I am expecting some kind of an amplified, more output. But if your transistor is moving towards the saturation region, now in that case, you are not able to work the transistor as an amplifier. It will be stuck. It is going to be saturated. Though you are providing the input, it is not going to be amplified and you are not getting at an output side. That happens whenever the collector is going to us, whenever the transistor is moving towards the saturation regions. Hence, if what the conclusion we are going to be made is that if this kind of the situation is arises, that is due to the VCE decrement, your Q point is moving or increasing, your transistor is shifted into the saturation region, and within the saturation region, whatever our basic aim of the building the amplifier, that is going to be collapses. Just, and this one is just because there are some kind of these DC components are present. Because of this DC component, this V is going to increase. Due to increment in the V, this VC is going to be decreased, and due to VC is decreasing, Q points moving upward, that is in the saturation region, and our transistor is not working as an amplifier. So our basic aim is going to be collapses. And just to avoid this one, we should have to use some kind of a circuitry called as a level shifter, so that this VE output is going to be decreases. Now, for this, we are going to use the level transistor. If this level translators, so if this VE is going to be decreases, then what happens? If V is going to be decreases, this VCE is going to be increases. And if this VC is going to be increases, Q point is going to be decreases or moving in a downward direction, that means towards the active region, and your transistor is trying to work as an amplifier. That is our basic aim. Now, our question is that, or our task is that, how to work or how to make this VE to be as low as possible. We have to go with this level translator. And what is this level translator consist of? Here I am trying to show you a very basic, very basic circuit of a level translator, which one is formed with the help of a voltage divider circuit. So voltage divider circuit, we should have to use this kind of two basic transistor. Here they are denoted with R1 and R2. We can consider the voltage drop across either R1 or either R2. How we are going to be write down the equation, that voltage divider that we have already studied. So in short, we can say that if I want to consider the voltage drop across the R2, what is the equation? That is R2 divided by R1 plus R2 into this minus of V. Okay, so this output voltage is basically depending only on the values of R1 and R2. So if I am just connecting it towards or measuring it towards the ground, this voltage drop is moving towards the ground, and this value of VE is going to be decreasing. So as this value, we should have to keep this output voltage near about the 0 volt. So according to get this value towards the 0 volt, we should have to choose the values of R1 and R2 so that this output voltage should be equal to 0. Ideally, it is not coming as on a 0 volt, but we should have to be keep it towards the 0 as low as possible, so that this VE output should be comes towards the 0, and hence your VC going to be increases, and Q point you will be get a proper Q point over there. Okay, so in this way, with the help of a level translator, we are keeping whatever the output DC voltage will be comes over here, um, uh, more or generated greater DC voltage will be just come over here. It is moving as we are connecting this interfacing this junction towards the 0 and adjusting the R1 and R2 value so that this output voltage drop down towards the 0. Though here DC voltage will becomes at the output of a transistor, we try to keep it towards the ground or towards the 0, and hence this VC values we are going to be adjusted. So in this way, our level translator is going to be work out. Okay, so that is the same one I have just, are you getting all of this one now? Just give me the reply on the chat, your chat box. Okay, so if you have any kind of any difficulty, please raise it. You can individually ask me, or you can place the message over here so that I can be replied. But these are the very basic concept. Please clear out all of your concept. If you have any kind of any doubt, let me inform. I will again explain it. Okay, in short, again I'm going to be explain that what happens for the level translators. So the level translators, this one is on the third stage. We have already seen that within our basic block diagram of the op-amp, within the basic block diagram of the op-amp, we have already seen that is this one is an input stage, intermediate, or the second stage, and this one is nothing but on a level shifting stage. For today's session, we are just going to be discuss about this one. So the input stage is nothing but an dual input balanced output differential amplifier. Intermediate stage is nothing but dual input unbalanced output, and hence here we will be get some kind of a DC output voltage, and that we are given towards the level shifting stage. Now in this session we have just discussed about this block, that is on a level shifting stage. So if the DC voltage is not at the proper or the ideal condition, then what happens we have just seen. Now due to this, that is what I want to say, that reducing the voltage swing is nothing but like this one with this equation. That is, if this how this transistor is moving, if the Q point is moving in upward direction, Q point is moving in a downward direction, that kind of the voltage swing will be available, and due to this we will be get some kind of an different output. To nullify this effect, we are using this level translator. So at the second stage, we can assume that this input is nothing but an output of a second stage. It will be consist of some kind of a non-zero DC plus of AC signal. So to measure this AC component accurately, this DC component should be kept as a 0. If they are not 0, then transistor not working properly as an amplifier. So to make it 0, we are keeping this output terminal or these emitters connected towards the ground with the help of a voltage divider network. This voltage divider network is depending only on the values of R1 and R2. So we should have to be choose the whatever the DC voltage is available over here. For example, here it will become as 2.3 volt. Now to make this 2.3 volt towards the 0, what should be the values are required? That in according to calculations, that is R2 divided by R1 plus R2, we should have to choose the values of R1 and R2. So this one is the remedy, that how the level shifting circuits are used. That is, I have just summarized over here. That is, in a cascading fashion, the voltage at the output terminal of the second stage may be well above the ground level, that is on a DC level, 0 volt. This DC level is undesirable because it tends to limit the peak-to-peak output voltage swing without distortion, and also contributes towards the error. That is, instead of the 0 volt, if we will be get shifted it is in a 2 volt, then output plus positive will becomes towards the 3 volt, and negative terminal negative voltage will becomes towards the -1 volt. So this kind of changes will be take out, that is in the peak to peak output voltage is going to be changed. and hence it will be contribute towards the errors in the DC output signal. So so to shift the DC output level, sorry so to shift the DC output DC level at the second stage down about to 0 volt, a special circuitry is required that is nothing but called as a level translator. Again, I repeat, to shift the output DC level at the second stage down towards the 0 volt. That is, we are keeping the 0 level DC voltage, and hence with respect to that, we can measure your output voltage to be in the equal fashion. So that kind of the signal is nothing but called as a level translator. Thus, in the cascaded differential amplifier, to shift the output DC level down to 0 volts, the final stage must be followed by the level translator circuit. It is according to our block diagram in the cascaded differential amplifier circuits. Okay, to put down the DC output level towards the 0, we will be required this kind of a translator circuits. Another one, that is the same one, I am going to be explain this one in detail about this and a voltage translate this kind of an uh, uh, this kind of an voltage divider circuit. So an emitter follower with the voltage divider is the simplest format of the level translator. Because of this one, the DC at the best, which one is available from the second stage, it is available as it is. It is given as an input to the base of the transistor. It will be produces a 0 output at the emitter terminal. And this one is going to be decided with the help of R1 and R2. So instead of the voltage divider, so there are the n numbers of another circuitry available as a level translator. In your syllabus, they have just mentioned that what are the types of the level translator. So with the help of a diode current bias circuit or some kind of a current mirror bias circuit can be used for the better result. What is this current mirror circuit that we are going to be discussed for the next lecture? So this kind of the and this another circuitry I am going to be provide you in some form of a notes. If anyone is interested, I am going to be explain it in detail about that one. But this one is on a simplest format. First of all, you will be get the concept, then again we will be discussing with some kind of an advanced circuit also. Okay, so this is some kind of an stages that we are going to be considered for the level translator. Okay, so is there any doubt for anyone? Yes, is there any doubt?